So I'm actually also from the Skeptics Estonia. So if anybody thinks I'm thinking too fondly about chiropraxis, then just forget it. This is, of course, kind of play on the question of actually trying to relieve something's stress, which is usually the concept of chiropraxis. But in our case, or in my case, the question is that I've been working in zone.ee now for 1.5 years, a bit more, and it has brought to me a lot of customers who usually come with the issue that something doesn't work, and usually we are to be blamed. Which occasionally may be also true, because when you are doing updates and stuff, then it can happen that something is acting sometimes weird, but most of the cases I've met are, I think, highly instructional. I'll be talking about my methodology and tools I'm using. From the first side, I like the most of the, and then that's also the source of the question of the chiropraxis, which is kind of manual therapy. So I tend to use very low-level tools like Top and MyTop, and a thing which is called Casustack. Does anybody know what Casustack stands for? Yeah. It's written there, so it's actually, I think the term is coined by Rene Drisberg and Swedbank or Hansabank guys. So basically, most of the things done with log files are done like that usually. He has been developing a very cool tool, Speedbox, which I have actually up here and running, and maybe I can give also a short glimpse of that. And for the rest of the stuff, I'm usually starting with very simple things. Actually, the first in the tools should be also Chrome's developer tools inspector, because before I ever think about looking at the back end, I'm usually looking at the front end. And it kind of gets rid of 75% of the things that server is working slowly. It's just that your front page is 10 megabytes and just get lost. But I'm not going to talk about that because this is the front-end stuff. I'm usually, when I find out the problem isn't related to front-end, I'm usually adding the very simple things like the ping term, just uptime monitoring, and seeing what is the response time of the website. It gives me the kind of temporal view, the four-dimensional view I see in how the response time or everything is changing in time. Because, as I'll be showing sometimes, there are exactly the changes during the, or on the simple response time that can tell what might be the problem. Another thing is that if you start with a website that loads like 12 seconds, and you are able to bring it down to 6 seconds load, which is ridiculously slow anyway, but you can show that the response time has dropped like 50% and cash in your money. The other tools I'm usually using is Neuralink. When I need to monitor a bit more what's happening during the site's live usage. I'm using it very rarely because it's hell of expensive if most of the jobs are looking for 2 hours at one website, then having the license and everything isn't worth that. So I'm usually just setting up a trial. Yeah.
But do you ever use anything of Neuralink beyond free tier? Because they have free tier that have like 24-hour retention, right? And this basically APM stuff, you got it there.
I think the free side does not give me so good look inside the functions and everything that's running. I kind of tried and found that the 14-day trial, which I have probably run through like, I don't know, tens and tens, is very effective in doing that quickly. Then there is something which is called Blackfyre, I think also .io, which is very cool in a way that I can have this one developer's license, which is like, I don't know, $20 per month. And again, I can very easily add the license to a particular PHP server, the server running PHP, the codes, and have a quick snapshot, and I can send out to you the link to the full trace. So that's what I'm usually doing if somebody is complaining that server is slow. And then there is something called Loader.io, which also has very nice free tier. I'm using paid tier for more than a year because I want to monitor a lot of sites and do a bit more. But mostly, most of these are pretty cool also on the free side. The Blackfyre, I've actually found that I registered a trial, and somehow it's still fully functional year after that. So I don't know how I did it. You can just try to reproduce that by testing. But I was supposed to speak about applications. Now, quoting me, myself, and I, fixing bugs is usually easy when you know there is a bug. I think this is the question of the yellow part of the pie chart. That it's pretty often that people don't know they do have especially performance problems with their websites because there is no load on the website. One of the very good historical examples of that is the 2007 so-called cyber attacks. Okay, there were also real cyber attacks, but most of the problem was related to the thing that nobody had ever actually thought about load testing their websites. Meaning that if the users came, then it didn't have to be malicious, it was just interest in what government is doing, which usually nobody cares, and it crashes. And when you know there is a bug, I actually had two versions of this slide. There's another one, is this one. There is only one very small change. So whichever you prefer. I've done some tests, and there are the interest is mixed. And the scope is about what kind of bugs. It's about Speedbox. So I'm talking today only about things that are somehow very stupid and make the websites crash when it actually needs to work. Most of the examples are formulated in the form of average letter to the help desk, which is, as emphasized, is about the question of our server being slow, not your code. And our server is slow. Okay, I need to explain a couple of things before we get to the apps part first. You probably know how application stack is running on a web server. There is somewhere below, there is virtualization or physical hardware, there is kernel operating system, there is some software platform with LAMP stack or whatever, and then on top of that is application. And in this case, the red parts are what we are responsible, and the gray parts are different services where a customer is responsible. But to understand where the problems are, and from the formulation of the sample letter, it is usually kind of telling that the problem is somewhere on the hardware side. So I have been trying different tools to kind of benchmark the base layer of what's running below your websites. The basic PHP program could be something like that. I've made up some fancy-looking function names to just do some kind of computations of different kinds to make it comparable. The real one has way less fancy function names. It's called benchmark PHP. Can be found possibly on GitHub, and well, it basically does the same thing exactly, but with slightly less interesting function names, as I told. And you can come to the result that you can actually compare two different servers and understand a bit about what is the performance, how fast something is working there. On the right side is my MacBook Pro, and on the left side is a random hosting server. I also went a bit deeper into the rabbit hole And I was trying at some point to understand how different VPSs and different server platforms that are offered actually compare side by side, and what are the differences and how to measure them. And when I was looking around for different benchmarking tools that could be easy to use, free, and for what I could already have also some kind of benchmarks, I found from this site something which is called Meta VPSbench. Again, a very simple shell script which is running through some SysBench tests for doing the computation intensive task, for doing IOPS intensive tasks, seeing the storage speeds, and also doing some database operations. Just to put different things in comparison, because I was interested to understand that if whatever UpCloud is telling that they have faster servers than anybody else, then how does that compare? Can I actually see the difference when I'm measuring something which is very specifically measurable? So I actually made an Ansible playbook, so I was able to deploy it to wherever I wanted and shot up a bunch of VPSs. The only problem place I actually found was DigitalOcean, because one core instances were actually pretty cool. And the moment when I went to the 2 to 4 core instances, then turned out that actually they are so oversold. So I was often getting only 50% of the processor cycles that I had paid for. So actually, the most time intensive part of that testing site was finding this hypervisor that did have enough capacity. It took me like half a day booting up and doing completely something you shouldn't be doing ever when benchmarking, picking the best of your competitors' offerings. I got a bunch of tables. Here in the yellow is actually some differences with meltdown batch under different loads, and so on. And basically I came to the conclusion that I can, if I know how oversold the instance is, then knowing the CPU clock frequency and a bit about storage speed, I was pretty easily able to predict what will be the rest of the things on the table. Well, and then was the question of how many cores. I decided to buy how much memory, which is the question of singular parallel requests. And okay, there was the question of virtualization. I found that, okay, apparently there are sometimes people who have put up miners on nearby systems. So this is actually a view of some time from one of our hypervisors. So some guy had legally purchased a number of CPUs or cores, was running there some kind of mining operations, which probably would have soon turned out to be not very profitable, and he would have probably not paid us, so we kind of nicely asked him to find something else to do. But the example was very interesting because I was doing at exactly the same time these tests, and I found how much that kind of a guy can actually have on virtualized environment, because there are often some limits on either the availability of processor cycles, availability of storage bandwidth, or something else, meaning that if somebody is actually trying to use all of the cores they think they have purchased, then the question is, it will be appearing very quickly that resources tend to be oversold. So, and from that I learned that whenever I'm using from the command line the top to see the processes that are currently running, especially on virtualized environment, the most important or interesting part is this number on the right, which is has the letters ST, which is called steal, which basically is showing what percentage of cycles are going, I think, which you don't receive. So basically, on this example, which isn't actually, sorry, my own screenshot, the rest of the screenshots are my own. This is from somewhere on the internet, but I did see on these 4 CPU instances, really when I put on the load, I got to the 60% of 50-60% of the steal. Something to look always when you are thinking that why your application speed is not growing as you think it should. I was supposed to speak about applications. Well, and then I actually added a bit to my Ansible's playbook, which maybe somebody noticed. There was also some lines about installing some WordPress and doing things. So I put on the same servers also a WordPress instance with WooCommerce and VPML for multilingual support. So your typical Estonian web shop. And then I used loader.io to put increasing loads on the servers. Not very high loads, but something to see if it's comparable. The cool thing is that, again, it turned out that the same tests were pretty well comparable to my processor and steal level tests. So usually when I'm speaking about server actual performance, I'm often speaking in the terms of these higher level, application level load testing, because going into IOPS and everything is probably too long a talk. So there is a huge sale shop which has just some sample products. There is the loader.io, which is putting on the free package. You can have one host, 1 minute tests, and 2 URLs for tests. This is usually, I think, and 10,000 clients per test. This is probably too much. Usually I'm finding that most of the simpler solutions tend to be crashable with something like, in our case, I'm usually running up to 30 parallel users, but in most of the rest of the places it's usually 2 or 3 users which will crash most of the hosting plans. So what I'm doing, I'm usually testing this with some things that I found that are giving pleasing graphs to show to people. Because if you just have some kind of flat line, it's very boring to look that this is the flat line and this is the flat line on slightly different height. I'm running from 1 to 30 parallel requests for 3 minutes and just hitting whatever front page without using cache. And this is the graph, what I'm getting. So it's running at some, let's say, minimal request length. Here is visible that the PHP processes are added, and here are some probably server's own maintenance things that are happening. And as you see, at the moment you are going to go past some kind of limits. In this case, probably it's 15 PHP processes that are allowed. The time is going to increase. But as the minimal response time is 300 milliseconds, then you can put a lot of requests into 1 second. And the resource consumption from the server side is low. Why I'm showing you this is that both from the, let's say, UX, from SEO side and everything, it's very important to bring the response times low. So it's said that everything that's in the size of 0.1 seconds, 100 milliseconds, is instant. Everything that's close to second is a noticeable delay for user, and 10 seconds is basically the point where user is going to fetch his beer.
Now we're, just to be clear, we're only speaking about landing pages, right? Because you normally only SEO landing pages. Like your real application with some recording stuff, you don't actually apply this kind of requirements to them.
No, I'm totally pissed off when I arrive at your web shop and I click on the category listing, and it takes, okay, let's see if I can demonstrate it. Okay, this is, I hope I have internet up. Okay, this is some kind of a web shop.
Oh, look, this is pretty much a landing page. Yes.
Yes, but what are you going to do as a user? I'm speaking on not only on the SEO side, but on the user side. You're probably going to go and look at whatever, some kind of garden stuff. Okay, this category has one product, it's working fine. And now, actually, your wife is coming to click and going to see on the kids stuff. Or okay, let's be gender neutral. Guys are also looking at kids stuff. Okay, and it was like 4 seconds. And now when you are running so that at least part of your web shop is running at 4 seconds for page loads, then you're going to have a problem. By the way, does anybody have idea why the categories are working at a different speed? What could be actually the underlying problem there?
Preload whole content.
Because they preload the whole stuff, yes.
Yeah.
Basically, yes, this is the question that they are doing, they are listing, I think, I don't know how many, 50 products. So they should be doing select category X, limit 10 page or whatever is the, in SQL, the page. But they are getting the whole category. I think last time I checked the kids stuff was like, I think the system is becoming low at around 6,000 items in category.
Okay, then maybe electronics will make it go nuts.
I don't actually know how many they have in electronics, but yeah, you are correct. Probably.
Yeah, it was lower.
Yeah. So, and also, and usually, again, I'm not going to go into currently too much deep because I have a lot of different samples. But you can just look at the network tab and see the exact timings and tell what's happening behind the scenes. So and actually, I told them that there is the problem, like I think at the beginning of year, and and what should be the solution, and they are still running it like that. So this is kind of a thing which is a problem. And it is also an important problem that at the moment when you have some pages on your application or some parts of your application that are acting slow, then what if a search engine comes to index that? Let's not care about SEO. It is just some kind of spidering thing that is hitting your website. And there are requests that are taking 4 or 16 seconds to run. They are completely starting to load the full stack of whatever resources are on the back end. So this means that it isn't the question of the speed of landing page, it's a question of speed of absolutely everything. So this is the part of running, and when you're getting the question that the min is low, then it should be pretty okay. There are different numbers for different kind of hosts. I think very interesting one is, for example, Radi Center that was barely running up to 15 requests parallel at the same application at 1.5 seconds. And then they switched to cPanel and started limiting users' resources. So basically, I totally like this picture. This is just kind of, come on, guys. This was just aborted, and these are just the 7 and 10 second responses that are still trickling back after the test was aborted. So this is Telia, this is DreamHost, and so on. So the question is that often the problem is that the resources the application is going to take are such that when you're trying it, it works. When you're going to load it, it's going to get bad. So this is why I'm always hitting them up with loader.io and seeing if there is a question that this site could be at least up during the loads. If it's showing me such pictures, then I'm telling that, oh, okay, there is no point in actually going into debugging the PHP. It will be crashing anyway. I found that this has very good match with the MetaBench results or the processor's capability. Usually, also with simple tools like Apache Bench. I don't know if anybody has been using that, but most systems tend to have something called AB included. So if you're doing AB, N is the number of requests, C is the concurrency, and the thing you're trying to hit up. basically you are DOSing something, so please be careful with doing that. You could be considered a cyber criminal by various laws. So basically it will be running very comparable tests, putting parallel requests, and you're getting very easily to know what's going to happen. I'm sometimes when consulting some kind of web shop, I've been trying out their competitors with very short bursts during off hours to tell that, okay, they will be dropping with that kind of campaign and they will be dropping with that kind of a campaign. And usually the loads coming from that are not visible in larger hosting servers graphs, so it won't be a problem. This is on one of these tests on our farm, so nothing to go red and to show something. About parallelism. This is what I'm usually, the next thing I'm looking when I'm looking at how the application is performing from the command line at the top and seeing the number of PHP processes launched. This is basically telling you how many parallel requests the system is capable of running, what are the limits that are often even not told to you what you can run, and the moment you are also, when you are looking at the site under stress and it's starting acting slow, I'm also going in and looking that, okay, first thing I'm looking is how many PHP processes are up. If it's close to what I think is limit, then I know there is something that is either there is high load, there is a lot of users, or there is something wrong which is keeping the site not running. Another cool thing which with what I have also example is called MyTop, like MySQL top, which is very easily showing all of the concurrently running SQL requests. And again, I have an example showing exactly how the problem looks like with that tool. And then with PHP, there is something which is called opcache. There is a possibility to with some simple PHP tool to look what it's actually doing. So if you are running something, what means opcache, it's basically a compiled or pseudo-compiled or whatever it's called PHP code. So basically most of the stuff you're running should be coming from opcache. If not, then you have something wrong with your system. So there is no point in reading in all gazillion files your application is consisting of and doing the PHP compilation. Absolutely no point. So in our case, this is something what I'm having up on our VPS side, which is and it just summarizes now based on these 3-minute tests. I think with less than 30 users. The questions of how different number of cores affects the actual performance of ability to serve parallel requests, and also, which was in this case interesting for me, was looking at DO's standard droplet and their amount of oversold quantity and partly possibly also processor clock speed. With ours, this was the test exactly where I was looking for DO's droplet that could perform. But especially as you see the difference in one core, which is the selling argument for developers, is let's say pretty comparable. And the moment you're moving your thing and telling that you can, with one click, you can add more cores. Okay, cool. And the difference grows very fastly, depending exactly on VPS providers' sales tactics. The same is the number of with the number of requests during some kind of time, because they are just opposite side of the same question. Oh, I was supposed to talk about applications. Yeah, sorry. Stack. Almost always when I'm hearing somebody is having a problem with their website performance, what do you think they're going to tell that needs to be changed here? PHP. Yes, let's put in Nginx, because it must be faster. How exactly? I'm never told, but suppose that there is a suggestion on Stack Exchange, and Stack Exchange can't be wrong because it's Stack Exchange. And I've earlier also copied code from Stack Exchange that worked, so this advice must be working as well. Operating system, doing low-level stuff and things probably doesn't change much. SQL version also I haven't seen that much of a difference. There are some differences with some configuration parameters, but in most cases when you have managed not to make 12,000 requests during showing your front page, the timing difference during the end result isn't very big. You are usually in SQL able to do much worse things than having a single parameter a bit differently configured. Also, if the Nginx change isn't good, then the next thing is tuning these 4 parameters of MySQL. This is actually the second solution, which should be solving all of the problems. Then there is something which is called FPM, Fast Process Manager, which is actually dealing with launching the PHP processes and giving them tasks. This is actually a thing which I've seen having problems, and some big ones. We are running our own FPM from pre-FPM times, but turns out there are some parameters that can, in some cases, act weirdly that. So there are situations when FPM can be a problem, but this is a larger problem that of the configuration. And then usually we are coming to the code. With PHP, there is also the thing which is we just got a letter from a public event which asked us to allocate them more resources for upcoming some kind of weekend competition, and they were running on PHP 5.2. I said actually, well, basically we could make your site whatever 4 times faster by just I don't know, 10 times faster, whatever is the difference of the height of the pylons here, by just switching to the PHP version, and then we can talk if you need to have more server or not. So, unfortunately, the question of running on older versions is huge. There are different tables giving all basically the same result. But now about the applications. And the first thing, as I said, is the front-end question. I'm not going to stand on that for a long time. I'm just showing you one random page from here, which has 2 very common, or three very common problems: missing images. Most of the CMS solutions tend to be when a file is missing, they are going to launch up all of their backend to find out this is a 404 error. Meaning that basically to show this page with 3 missing images, the application is booted up 4 times. This is probably a very stupid load. I have another example from at some point, which is having a application that tended to crash the website during campaign, and there is a main cause that I'm going to show, but one of the causes was also that the front end was making, I think it was 6 or 10 calls that were served by instance of Magento. Not putting up full of the front end and doing all of the things, but providing something, but it was basically separate PHP processes and separate launches of the Magento. So considering how huge it is, it's just a really stupid thing to do. So what I'm usually doing, I'm looking up here, I'm looking in the inspector at the number of different files. Okay, here is 54 requests for everything. This is actually pretty good because this is my sample shop. 800 kilobytes transferred, which is cool. Finish at 26 seconds. How can that be? Ah, okay. there is one thing. You're probably working in IT company and you have a fiber in your office. That's fast thing. You should never develop using fiber. You should have something which is doing the traffic shaping in the middle. The easiest thing is actually Chrome Inspector's possibility to just switch something to something slow. And then see how the web page looks. Usually it looks awful. It looks also awful to people who are not sitting in your office. One of my first loves with debugging performance tests was related to one of Estonian state registries. How long you're looking at time?
No, it was like 15 minutes.
Okay. So I was thinking I was already over time. So was with one of state registries that managed to, I think, saving of some kind of application took, I think, like 2.5 minutes. And it turned out that it was sending the data to the server in a manner of sending the data, waiting for something like 15 seconds. If the data hadn't been completely sent, then sending again. So it was basically a suicidal client-server application that was able to stuff everything into the channel. But mostly backend is the killer part. And so come in the letters to the help desk. This customer is running on a dedicated metal server, so everything should be fine. Well, for some reason it's running slow, and it has becoming slower and slower over the time. This is actually not the slowness graph from the outside, but from the inside. This is the server's load graph, and if somebody doesn't know what the load shows basically, I think it's correct to say, like sys calls which are waiting in the queue or something like that. So basically, tasks to be done. If it runs on the level of number of cores you are having in the processor, this is basically just there is always something to do. And if it gets much higher than the number of cores you have, then you are going to have what's called a problem. So I don't know actually what exactly was done here. You see the graph is very nice, and there was probably some kind of a change in the code. Nobody confessed to what they actually fucked up, but probably somebody did something.
Maybe
and
it was a successful campaign.
No, this wasn't definitely the case. There might have been something different. And it's going up and up and up and up. And I started looking at what's the problem. And I started counting different user agents. So this is actually a table I'm usually making using Spectix, because I like to take in large log files and just count things from the log files to get some understanding of what's going on, which was terribly difficult for me to do using GazuStack or just grabbing the log files. But with Spectix, it has been something that I'm often even not putting the ping-tom on the site before I just get the log files and run it through Spectix to see what has been happening during some time. So it's visible that the short is the PHP request served under 5 seconds. Long is those that are served over more than 5 seconds. Average is the total average, and static is the number of static like images and CSSs and everything loaded. We're seeing that the static is pretty much static all of the time, and the number of requests is growing to the point that it's having during a day number of very long requests. And in the parallel, I'm having the request coming from the Yandex bot. And turns out that Yandex had been increasing their load, and we reached the point that 40% of requests were coming from search engines. Or basically, from Yandex, I think there are other search engines as well. So my simplest solution to these things is that there are good search engines that are respecting robots.txt file. So if you're looking for on GitHub Petscrate and robots text, there is a sample way for Magento. It can be usually configured for everything else very easily. So Googlebot image let it go do everything. Yandexbot, crawl delay, make it crawl slowly, and disallow all kinds of query parameters, because the worst part of search engines is especially these web shops and things like that, which do have configurable options, is that they are going to go deeply into, let's say, even the paging. You can have paging with 10 products per page, 20, 30, ordered by price, ordered by, I don't know, color, whatever. There are filters like I want to have it red and with less than 20 euros and so on, everything combined. It gets to a lot of parameters, and nothing of that is usually cached, because these are all unique records, and all of your nice caching strategies and everything just don't work. So putting this one up actually resulted in this thing. So basically, and this is the I think it's 8-core hardware. So basically, it was consuming 6 cores for search indexing. Of course, the application is also probably not very optimized. This is the separate question. Now the question is, what remained? These peaks. What could these be?
Deploys?
Huh?
Deploys or maintenance?
No.
Maybe some reports.
No.
If PHP restarts.
No, for 1 hour. No.
And then cache reloading or something.
Cache reloading could be, and it's sometimes showing comparability to that. Huh? In this case, it was a competitor scanning the website. Or maybe a partner. I don't know exactly their relations, but somebody was scanning the website for prices, web shop for prices twice a day, very actively. And the system was not optimized to that kind of a load, so it went up. I think, and they were scanning, I think, not very much. It was like, I think, 3,000 or 4,000 pages per 2 hours. This isn't even something I would call offensive tactics, but I don't know. Please just create some kind of XML file so they can get it. They're going to do it anyway. Oh, another Magento. I totally love Magento. It's doing so many wonderful things. This is an interesting thing that I found on multiple occasions, that what is making a website slow is menu. Your categories menu. Because categories are often something which is not very easily indexed. It's somehow gathered using multiple SQL calls, and the menu is built by some for loops and everything, and it just takes fucking long time.
With M+1 and stuff.
What?
M+1 thing. Like every subcategory.
Yeah, something. And especially if the customer has asked to have a number of available products in the menu, because then it definitely must be recalculated every request, because maybe somebody has bought something and then there is now 1 item less in the category. The shop is selling, I don't know, 10 items a day. Come on, just use cache and cache specific parts of your HTML. You can maybe have the rest of the page built from scratch, but just make sure that the things like category menus, these are the worst. These are, I'm seeing so many problems with in all platforms, not only on Magento but also on WordPress. WordPress is especially bad with that. But everything which is category menus, and also like the Austria example was categories again. Just think where the people are going, not only about their landing pages. And here is, okay, this is mega menu, and there is also some kind of super categories block list or something else. Again, a lot of time. If there is also somebody dealing with Magento, then there is my favorite table is called core URL rewrite table. It is usually something like, if you have, I don't know, 5,000 products, it's like 1.5 million lines and growing daily.
Not at first. Not at first. Just slowly grow.
Yeah. The problem is what I'm calling Magento's matching URLs. So if a URL ends with a number, then during the next regular indexing, which is happening by the cron usually during the night, it's finding that, oh, there is a product with a number 1 at the end. Probably, let's add number 2 for whatever reason. And the next morning it's looking, oh my God, I have products with 1 and 2. Let's add 3 or something like that. And it's growing and growing and growing and creating the redirects from the product from with a number 1 to the number 2 to the number 3 to the number 4 and so on. And I think during the 1 year you are going to have 350 whatever 6 instances, unless your Magento has crashed in a meanwhile. So looking at the things like what are the actual requests, what it's doing, and also I'm always putting my hand on the database server and seeing if the database server is shaking. Okay, I'm looking with PHPMyAdmin on the tables, sorting them by the number of rows and looking at what has a lot of rows. What could be the reason there are 1.5 million rows in this table? Is this table needed at all? There's often tables like some kind of visitor logs that are doing database write on each and every page view. Do you need it? Is somebody looking at that? Is some functionality depending on that? Or it just nobody knew that it's collecting the data? And the result is databases that are gigabytes in the size. And if there is ever a question of the crash of the database server, the question of rebuilding that database is a nightmare. This one is very cool. I actually went to the customer site to actually debug that one. Works everywhere, it seemed to work, but not in their office. So I went there and I added the Blackfyre IO, which is pictures I'm going to show more also. And I hit reload on the specified gallery page, which was supposedly acting slow. And it's the longest trace I've ever seen being made. It took about 20 minutes to process a PHP page load and send it to the Blackfyre server. And it turned out to be a very simple result. The 18 seconds, I don't know how 18 seconds grew into 20 minutes. I don't know, but whatever happened back there, it's a mystique to me. But there was one request, get host by address. This is a fancy thing which you could use when you are doing something like anti-fraud or something to get from IP address the host name for whatever reason. And they had it somewhere in their code in different places related to this gallery for, I don't know, why they were doing that. And the problem was that they had asked from Telia, which was their connection provider to Office, to have a named pointer address or the reverse lookup from IP to have nicely their company name in or company domain in reverse lookup. And I don't know what exactly was wrong, but probably the DNS server is supposed to serve that were down or something like that for a long time ago. So basically a simple thing of checking for reverse of IP address when reversing doesn't happen in PHP can kill your site dead. Also, this is not the first and the last time when I've seen that something which is doing to log something very nicely has been crashing major problems. Oh, this is one thing when I'm not naming a real person. This is Signe from Eesti E-kaubanduse Liit, who really came to me asking, Peter, please look, I'm having this campaign. This is very important. Can we for once look at the campaign performance before it happens? Because they had crashed 2 last times.
Center flowers. Center flowers for doing this.
Yeah, I've been doing other favors for her. This was some kind of, let's say, Black Monday-like campaign, and when I looked at the code using New Relic, it turned out to be in some kind of whatever OMC speaker part, and the code was that. It's also on my blog, so maybe somebody has happened to read that. but can you spot the problem in the code?
You get the image size of the link.
Yes, but the image size is converted into local disk address. So the image size, it was like 150 images. Getting the size of 150 images from SSD shouldn't be a problem.
The variable name is wrong too.
What?
Like the photo is not photo.
Yeah, the problem is exactly that they are actually doing here this one and still using the original one. So they convert it to local address, see that there is no HTTP, and then they are doing to do the get image sizes. And I don't know, probably somebody has been testing the code and adding the underscore. If you add underscore before the name, it would be visible. But at the end of the name, it's completely invisible. So actually, I spent really 2 hours. I knew that if I commented this part of the code out, it works. If I leave it in, it doesn't work. And our devs, I think there were 4 people of us looking at the code and not understanding what is wrong until I noticed this one. Ah, shit, that's the problem. So just lousy coding practices. This one is from like 2 weeks ago. Someone told me that there is a problem with SQL Server. I'm doing this very simple call. And it takes like, I think in their case less, but in my case when I tried it, it took 16 seconds. On the SQL, and they said that on test pages it works correctly. On the live page, it takes like seconds to update the counter. Okay. What could be possibly wrong? Okay, indexes. No, indexes are correct. Okay. Optimize the database, everything is okay.
Triggers or something?
No, very simple data. Huh?
Is the ID column unique?
Yeah, I think the column, I don't have a slide here, but the more interesting part was actually, because I'm running out of time, I'm running a bit over the things. I was looking that it was just some selects that were taking like 3.5 seconds. How can a select take 3.5 seconds?
20 million rows.
Yeah, it wasn't that big. I think it was like, I don't know, maybe 5,000 products or whatever it was. So not a big table.
Lots of joins?
Yeah, exactly, yeah. There was, I think even not the question of number of joins, but probably there was something wrong with logics, and it was some kind of going into some kind of loop or doing something with joins. So what I found that actually having worked with PHP for a long time, I found just this spring that there is a possibility in PHP MyAdmin to look at the database status and processes. So as easy as you can do anything else with a database, you can also see what are the ongoing requests, and very easily from the most user-friendly part see what's wrong with that. Another one is mytop from command line showing the same thing, but yeah. Okay, let's go over that.
What was the issue with SQL, like with updates? With update, there were no joins. So what was the issue?
The issue was the live system. Because the I think did I have here? It was examining 5.6 million rows. So somehow it took all of the attention of SQL Server. So when the live system was running, the question wasn't in the update sentence. It was just that the SQL was under the live load, for some reasons performing slowly and locking the databases. Again, fortunately for me, for a lot of problems, it's enough if I show that, guys, you have problems with these joins, go fix them. And that's the part. This is one cool thing again from databases and Magento side. and growing databases. When Magento has it's keeping the cron jobs in SQL table. So whenever you have a system, always look at the SQL tables, because usually the cron jobs are kept there. And this was because we had migrated a website, and one of the Magento's jobs was running during the migration. And on a new server in the database, it was marked as running. And Magento kept adding tasks to the cron jobs table. And on each cron run, it was going out and updating each of, I think, 17,000 lines one by one, and causing that kind of a load. This is also very quick one. I made a PHP test file, which is loading like 4 seconds. The test file was this. File name .php and containing just some words. What could possibly be wrong? Not exactly.
Zone.ee is slow.
Your server is slow. You have something wrong with your PHP, was I think the question.
That's the very reason everyone doesn't use PHP.
Yeah. No, again, looking at the thing, it turns out that it was doing, this page was doing 3 web requests using WordPress's some kind of firewall. Okay, the tool had installed something called .user.ini in the root of the application, which means that each and every PHP request is going to use this prepended file, which was launching some kind of firewall, which was for whatever reason not performing well. Okay, I'll go over. This is this one is also cool. This is from the suicidal ring of Estonian bloggers, who usually like to link to each other's blog and show each other's news items in the sidebar. So there was one blogger whose name starts with M, and that's not the one who you're thinking probably. And the page loads like 15 seconds. And then when I looked at the request, it turned out that they were all trying to load pages from another well-known blog, which for whatever reason was failing. So basically, because everybody else was depending on everybody else's RSS feeds to work, and RSS feeds were cached, but only if the load was successful. Then in this case, it became unsuccessful, and the system was going worse and worse all over the time. This is boring. This is again the question of looking at the tables and the indexes with WordPress. The worst table is actually called VP options. And if you're running it together with WooCommerce, then WooCommerce tends to, and a lot of other things tend to use it as a dump ground for everything that should go into the temp folder. So basically all kinds of transients and things go in there. There is one column which is called autoload, which has value yes or no, and which is not indexed. So if you have a web options table with, I don't know, tens of thousands of rows, then it is kind of a problem. And and this is I think the last example, which is about a campaign crashing a website again. And I had been actually looking at the website and telling that I'm having the ping up, and I just took into the Excel the list of the responses for last time and sorted it by the duration of request. And it turned out that everything that is like 7 or 8 seconds long is happening at 0.10, 0.40, basically usually at 10 or 5th second, and everything that takes like 2 seconds is happening at 51 or something 6. It does look like cron job. And when the campaign came, in our case, we have one interesting feature is that we are adding in Apache log files to each PHP run, also the time it took to run the PHP, which makes it very fancy to actually look for a request. You can even use the Kasustack to look for requests that have been longer than 0.0 seconds. And putting it again into the table and seeing when things are going bad, it turns out to be 05 or 011 niche. And I think there is on the 15th, I've taken a part from that, where I am seeing the exact request. That is some kind of REST API call, which is probably whatever the cron was doing. Locking databases and crashing the system during the campaign. Everything was working very finely during normal daily operations, but the moment there came the load, it ate up all of the possible PHP processes and everybody was waiting for everybody else.
So it means your server is slow.
Yes, basically it means that the server was slow. And actually the idea to solve the problem was that there is a need to have a cloud solution. Because in cloud you can always add CPU cores.
Yes, and also in the cloud.
Until some point when you're coming to the number of physical cores on your server, then it's just our possibility to sell you more cores. But you still have the same number of physical cores, and you must move out from the land of monolithic PHP applications into something which is more cloud ready, or you just need to look how not to crash the system with your cron jobs. Thank you.